Welcome to another episode of Quick Tech Tips and Reviews. My name is Tony, and with this channel, I try to bring you guys a variety of different tech-related content. So, if this is your first time with us, please consider subscribing to the channel and make sure you hit that little bell so that you're alerted to when I release new content. In today's video, we're going to take a look at how to connect two edge routers using the basic principles of static routing. Okay guys, so recently I had a viewer ask how to connect up two locations using static routing. Now the user has edge routers in both locations and they have internet coming into one of the locations. So the end result is they want both locations to be able to use the same internet connection as well as have both local area networks communicate with each other. So that being said, I don't know if this is for a business setup with two locations or if this is just a residential scenario where they're trying to connect up and share internet services. I'm not sure, but in any event, we're going to take a look at how to connect up the two edge routers using static routing. Let's take a look at this diagram and see what we have going on. So we're working with two edge routers in this scenario. Let's look at this diagram. On the left, we have an edge router X, which we'll refer to as router A. And on the right, we have an edge router X SFP, which we'll refer to as router B. Now, we have the internet coming into ETH0 on the edge router X, and then we have a local area network hanging off of ETH1, as you see here. Over on the right side, we have a local area network hanging off of ETH1, and then we have created a network between the two routers. On router A, we're using port 4, and on router B, we're using ETH0. And we assigned an address to router A, ETH4, of 10.0.0.1, and router B, ETH0, 10.0.0.2, hence creating a network between these two routers. Now, in a real-world situation, you can also, depending on the distance and the scenario, use a wireless point-to-point if the locations are within close enough range. That being said, for the purpose of this video, I'm just going to simulate that connection or that network by using an Ethernet cable and directly connecting both of these routers. Now, when using static routing, the information that you need to know is the next hop gateway address and the destination LAN address. So in this case, for router A, the next hop gateway address would be that of router B, 10.0.0.2, and the destination LAN would be 192.168.1.0/24. In reverse, for router B, the next hop gateway address would be that of router A, 10.0.0.1, and the destination LAN would be 192.168.100.0/24. Now, I know that may all seem a little confusing, but I think it'll make more sense once we get to the actual configuration. That being said, let's go to the edge router X dashboard. Okay guys, so I'm signed into the edge router X, router A in the diagram. Now all I did to configure this router was run the basic setup wizard out of the box. If you'd like to see how that's done, I'll put a link to an unboxing and setup video up above. Before we start configuring this router for static mapping over to the edge router X SFP, let's take a look at the default configuration we received from the setup wizard. So we have our WAN port on ETH0. You can see the status is connected. Now don't mind the private IP address. I just have that plugged into a switch on my main network to simulate the internet. In your case, this should be a public IP address that's issued to you from your ISP. I have this computer plugged into ETH2. And then we have switch 0, which consists of ETH1, 2, 3, and 4 by default. The wizard also set up the default firewall rule sets for WAN in and WAN local, as well as a default DHCP server for the local area network and the DNS configuration. So, that being said, what we need to do to start configuring this router for static mapping based on the diagram, we need to configure ETH4, but before we can configure ETH4, we need to remove it from switch 0. So let's do that now. Let's come over to switch 0. Let's click on the actions drop down and select config. and we're presented with the interface configuration for switch 0 dialog box. Let's click on the VLAN tab and simply uncheck ETH4 and click Save. Now that we've removed ETH4 from switch 0, we can configure it and begin the process of developing the bridge network for our static mapping. So we're going to come over to ETH4, click on the Actions dropdown, and select Config. And we're presented with the interface configuration for ETH4 dialog box. So we're going to give it a name, and I'm going to call this Bridge Network. We're going to assign it a manual IP address. Now, based on that diagram, this address is 10.0.0.1/24. So we'll go ahead and we'll say Save. Okay, so now we have ETH4 configured on the 10.0.0.1 address. Next thing we need to do is let's go over to the Routing tab, and we'll take a look at the routes that the router created by default as a result of the wizard. You see all the connected routes and the one static route out to the internet, 0.0.0.0/24, refers to the internet. And it's getting there through my main router, my main network, which is the Next Hop gateway. Now that being said, we're going to add the static route over to the EdgeRouter X SFP, even though we did not configure that router yet. Remember what I said when I was showing you the diagram. You need to know two pieces of information to create the static route. That's the next hop address and the destination network. So we know that information. We know that the next hop address for router A is going to be the gateway of router B, which is 10.0.0.2, and the local area network destination on router B is 192.168.1.0/24. So we have the information we need to create the static route from router A to router B. So let's click on Add a Static Route, and we're presented with the Create IP version 4 static route dialog box. Select the route type. We're going to leave it set as gateway because that's the type of route we want. And the destination network is 192.168.1.0/24. And the next hop address is the port either 0 on router B, and that is 10.0.0.2. You can give it a description if you want. I'm just going to leave it blank for the purpose of this video. And the distance could be any number from 1 to 255. This is an administrative distance. It basically means the ranking of the routes. So the lower the number, the more preferred. So I'm just going to leave this set to 1. Make sure it's enabled, and we're going to click on Save. And there we go. So now we have our static route over to 192.168.1.0/24. The next hop is 10.0.0.2, which is going to be router B, the EdgeRouter X SFP. And then it is a static type route, and it's in FIB. So that is good. So we are done here. Now let's switch over to the EdgeRouter X SFP and begin the configuration on that router. Okay guys, so I did a factory reset on the EdgeRouter X SFP, so it simulates it coming right out of the box. That being said, I'm plugged into ETH0 so that I can get to manage the router. You can see I set my network settings to an IP address in that 192.168.1 range manually. And when the router comes back up, it says it's in default config, and it asks, do you want to start off with the basic setup wizard? So I'm going to go ahead and say no for this. Okay, so what we have is ETH0, and it's on the default router address of 192.168.1.1. Now, we're going to digress. We're just going to make one minor modification from that diagram. Originally, we were going to put the other side of the bridge network on ETH0 and hang the 192 network off of ETH1. So we're just going to reverse that, but basically the whole concept of static mapping does not change. So we're going to leave the 192.168.1.1/24 on ETH0. We're going to go into ETH1 now, and we're going to configure that as 10.0.0.2, the other side of the bridge network. So we're going to call this bridge network. Instead of assigning it an address from DHCP, we're going to give it a manually defined address of 10.0.0.2/24, and we're going to go ahead and say save. Okay, now that we have that established, the next thing we need to do is we need to go into our services tab, and we need to add a DHCP server for the LAN. So we're going to call this LAN, and we're going to give it 192.168.1.0/24. And just for the purposes of this video, we'll make the starting range 2 and the stopping range or the ending range 254. We're going to make it 1.1, and we're going to use the same for the DNS server, and we could pop in a public DNS here of 1.1.1.1, and we'll go ahead and we'll say save. Okay, now we have our DHCP server set up. Let's go into DNS and let's pick the interface. So we have our LAN on ETH0, so we're going to have our listening face on ETH0, and we could just set the cache size to 150. And we'll go ahead and say save here. Okay. So ETH0 has our local network, our local area network. ETH1 is the other side of the bridge. We're not done yet though. Let's go into the firewall NAT tab. Let's go into NAT, and we need to create a source NAT rule. And we're basically going to call this out to bridge. We're going to say that the outbound internet in this case is ETH1, and we're going to use masquerade. And then we're going to come down and say save. Okay. Now that we have all that in place, we should be able to connect a cable from ETH1 on the EdgeRouter X SFP over to ETH4 on the EdgeRouter X, and we should get a connected status. So I'll be right back. Let me do that. Let's see what happens. Okay, guys, so let's see. So we have a connection or a connected status on the bridge network on ETH1. So now let's go over to the routing tab, and let's add a static route over to the internet. So we're on router B now, and what we want to do is make a static path or a static route over that bridge network over to the next hop on router A, which is 10.0.0.1, and then out to the internet. So the type of route we want to use is a gateway route. The destination network in this case is the internet, which is represented by all zeros. So 0.0.0.0/0. The next hop address in this case for router B is going to be ETH4 on router 1, which is 10.0.0.1. We can call this internet, and we'll assign the administrative distance of 1, meaning the most preferred. We're going to go ahead and say save. Okay, guys, so I've changed my network settings back to DHCP, as you can see here, and I have DNS information as well. So I should be able to get out to the internet from router B, going over the bridge network to the next hop address on router A, and then out to the internet. So let's bring up a ping tool and run a couple of different tests. So let's start off by pinging Google. and you can see we're getting a successful ping. Let's ping Google again, but this time let's ping the domain name just to make sure that DNS is resolving properly. And you can see, guys, we're getting a successful ping from there as well. Okay, let's do a clear screen for a second. And let's do a trace route just to see what's going on. And we'll trace route over to google.com. And just to take a look at what's happening, let's go back to here, get to the top there. And you can see here, we're starting at the gateway 192.168.1.1, which is router B. It's hopping over the bridge network to the next hop on router A of 10.0.0.1, and then it's going out the main router to the internet. Now remember, I was simulating the internet to the edge router X off of my main router, and that's what this is. So everything here is working as expected. So the next thing I'm going to do is just flip around. Oh, no, one more thing I forgot. I do have a PC hanging off the network on router A. So I'm going to be able to ping from router B now to router A, that PC. So let's see. So let's bring up a ping tool, and the address of that PC is 192.168.100.39. Now remember, I'm in a remote LAN with the address of 192.168.1.2. So you can see here now I'm getting successful ping across that bridge network over to router A. Okay. Now I'm going to stop the video for a second, flip around the two computer Ethernet cables. So example, this computer is in router B and the other PC that we just pinged is in router A. Now I'm going to flip that around. I'm going to put this computer in router A and that PC in router B so that we can test connectivity from router A's LAN to router B's LAN. I'll be right back. Okay guys, so I've flipped the cables. So now I have this PC plugged into router A. I have the Windows laptop plugged into router B. I have an address here, as you can see on the screen, of 192.168.100.38. And the Windows PC over on the other router has an address of 192.168.1.39. You're going to have to trust me on that one, guys. So I'm going to bring up a ping tool, and we're just going to make sure that we can ping over from one LAN to the other. So we're going to say ping, and the address is 192.168.1.39. And there you go. We have a successful ping. Now, some of you might be thinking that the way this is set up, that I could ping the router and access the router from each respective local area network, and that is true. And I'm going to leave it for now. I'm aware of that. I just put this video together based on requests that I received where they wanted full connectivity and they just wanted router B clients or hosts to be able to get out to the internet through router A. So that being said, yes, I am aware that hosts from both remote local area networks can access the remote router. However, that can be locked down with a simple firewall rule preventing that. And maybe that's a topic for another video. So there you have it, guys. If you liked this video, found it helpful, and would like to see more videos like this, please give it a thumbs up. Be sure to check out some of my other videos up above. You can help out the channel by remembering to subscribe, give the video a like if you haven't already, and share the video. And remember to use those Amazon affiliate links down in the video description below. I know they don't change your price, but they do help out the channel. My name is Tony with Quick Tech Solutions. As always, I thank you for watching. See you next time.